let's solve for this equation. 2 times cubic root of 2x plus 1 equals x cubed minus 1. Solve for real value of x. Now, if we rearrange it a little bit, say cubic root of 2x plus 1 equals half of x cubed minus 1. Now, before we cube both sides, I'd like to observe a little bit. So the left-hand side pretty much look like the inverse function of this function. Let's verify that. If I say f of x equal to half of x cubed minus 1, let's call that y. Now if we solve for x, so x cubed minus 1 equals 2y, then x should be equal to 2y plus 1, then cubic root. Now this really, so in other words, x is equal to that, so that means f of the inverse function. Inverse function. That's the meaning of inverse function, right? Represent x in terms of y. So inverse function just replace y with x, cubic root of 2x plus 1. So really, in other words, if we want to solve for this equation, we say, when does the inverse function equal to the original function? When does this happen? What kind of x makes this true? So from the graph, we say this is 0, x, y. Now f of x is this one, so strictly increasing. Strictly increasing. When x is equal to 1, that's equal to 0. So 1, 0. Strictly increasing. Increasing. And also here's decreasing like that. So the inverse function should be symmetrical according to the 45-degree line. The 45-degree line here. So y equals x, straight line. And so here's y. Should look like something like this. Now, they only equal to each other when at this point, meet at this point, 45-degree straight line. So that means this is when x value is equal to the y value. X naught equals y naught. Right? And not only that, down here, the graph will look something like that. That's the inverse graph of the inverse function, or the graph of the original function. And the inverse graph is like this. Then like this. Yes. So they meet here. They also meet here. So this is when there is this point called x1. So down here is y1. Here is x1. x1 equal to y1, both negative. And they meet here. So here is y2. There is x2. So x2 equal to y2, both negative. So I believe there are exactly 3 solutions. Solution up here, down here, and down here. And so in fact I say x naught equal to y naught, x1, y1, x2. So generally x equal to y. So which means x equal to y. So what x equal to this part. X equals exactly x. And so x cubed minus 1 equals 2x. X cubed minus 2x minus 1, 0. So if we let x equal to negative, let me see, negative 1. So negative 1, this becomes negative 1, like plus 2, minus 1, exactly 0. So we immediately know that one of the factors is x plus 1. Right? That's a factor. So we can either use long division or just simple factorization. So let's try use long division. So this divided by that factor. So divided by x plus 1, we have x cubed minus 2x minus 1. So I can come up with some number multiplied by x gives me x cubed. So I get x squared multiplied by x cubed and also plus x squared. And so this minus that. So this is gone. And this I have negative. So I have negative x squared and copy this now. Negative 2x, negative 1. And so I can come up with negative x, because that's going to give me exactly negative x squared, and also minus x. And so this leading term is gone. So this minus that, so this plus that, negative x minus 1. And I'm going to come up with negative 1 here, because negative 1 multiply that. Negative x, negative 1. So exactly the remaining of the factor is this. Right, so essentially we're trying to solve for this. Minus x minus 1 equal 0. And for that, we can say x is equal to half of negative, so positive 1 plus minus square root of 1 plus 4, 1 plus 5. Two solutions, and we have this solution x equal negative 1, exactly 3 solutions.